Derivatives with logarithms, chain rule, Leibniz's notation. Here we have a function log to the base of a x. If we wish to derive this, we end up with 1 over x ln a. So the base is what we have. The base is a, which is a number like 3, 4, 1000, whatever, and x is the variable. When we derive log to the base of a number with a variable, we get 1 over that variable multiplied by natural log of the base. I'll do an example to show that in a minute, but right now that's just the general rule. Here is the chain rule. Not Leibniz. Lagrange's notation. The way he does it is he has a function hx, and within that function there's a function within a function. So you've got gx within f of gx. And when you derive hx, you end up with the derivative of f with respect to gx, and then you multiply it by the derivative of gx. I'll explain all this as we go, but that's just an outline of what we'll be doing. Here we have, I'll start with example 1. This won't be the chain rule, this will just be a way of doing it. Showing you an example of deriving a logarithm. So you have log to the base of 2x. When we derive this, we end up with 1 over x ln 2. So the base, you can see the connection. The base is what is in is what we multiply by a natural logarithm, and the x, the variable, just multiplied to the ln2. See how that works? As I can't really explain an incredible amount. I will do a proof video on this, but this is just the general rule. This is just how you would do it. It's pretty easy to implement. But for now, let's do an example involving the chain rule. So here we have log to the base of 3 e to the x. We have a function within a function. Because we only have a function within a function, we only have one function inside another function. So the innermost function is gx, and the innermost function on log to the base of 3 e to the x is the e to the x, because that's the innermost function and that's the innermost function. Therefore, f of gx would be log to the base of 3 of gx. The derivative is the derivative of f with respect to gx multiplied by the derivative of gx. So we need to find the derivative of gx and the derivative of f with respect to gx. If e to the x is gx, then the derivative would just be e to the x. With log 3 gx, the derivative of log to the base of 3 gx would be 1 over gx ln 3. Just like before, when you have log 2 to the with log to the base of 2x, you end up with 1 over x ln 2. Log to the base of 3 gx, you end up with 1 over gx ln 3. Filling this in, derivative of f with respect to gx is 1 over gx ln 3 multiplied by derivative of gx, ex. We end up with ex over input gx, ex ln 3. We can cancel the ex from the top and the bottom, and what we're left with is 1 over ln 3. And that is the first derivative of log to the base of 3 e to the x. Do another example. We have hx equals log 7 x to the power of 3 over 3 plus 1. We still have, just like before, our function within another function. So we have gx within f of gx, just like x to the power of 3 over 3 plus 1 is within log to the base 7 x to the power of 3 over 3 plus 1. We'll get the innermost function, x to the power of 3 over 3 plus 1, and we'll label that gx. Then we'll get f of gx, which will be the outermost function. We'll have log 7 gx. If we derive hx, we get the derivative of the outside function with respect to the inside function and multiply that by the derivative of the inside function. So we need to get the derivative of the inside function and the derivative of the outside function with respect to the inside function. The derivative of x over 3, x to the power of 3 over 3 plus 1 is just x squared. Because you bring the 3 down and it'll end up being 3 over 3, which is 1. So 1 times x to the power of 2 would just be x to the power of 2, which is x squared. The derivative of log to the base 7 with gx is just 1 over gx ln 7. That doesn't really fit, but I'll rewrite it out here so you can see it a lot clearer. Derivative of f with respect to gx, we end up with 1 over gx ln 7 multiplied by derivative of gx, which is x squared. Simplify it and rewrite it. Input gx and that is the first derivative of this function up here. Let's do another example. One more example, I should say. hx equals log to the base of 8 sine x. Our innermost function and our outermost function. Our innermost function is gx. Our innermost function of log to the base 8 sine x is sine x. that means that f of gx, our outermost function, is log 8 gx. The derivative of hx equals the derivative of f with respect to gx multiplied by the derivative of gx. If we have gx and we can find the derivative of gx, sine x, the derivative is cosine of x. Derivative of gx, the derivative of f with respect to gx, if f with respect to gx is log to the base 8 gx, then the derivative is 1 over gx ln 8. If we fill this in, 1 over gx ln 8 multiplied by derivative of gx, which is cosine of x, what we get is cos x over sine x ln 8. And that is the first derivative of that up here. I hope this helped. Thanks for watching.